You know that feeling when you're facing a problem that feels, well, impossible? So many moving parts, so many ways for it to go wrong, that a single person could never solve it? Well, today, we're going to build a machine that can.
Picture this. You've planned the trip of a lifetime. 2 weeks, multiple cities. It's a beautiful, complex dance of flights and hotels and tours. And then, it starts. The dominoes begin to fall. Your first flight? Canceled. Which means you'll miss your connecting flight. That boutique hotel you booked? It's non-refundable, and now you're booked for the wrong night. Your perfect trip has just exploded into a total logistical nightmare.
So, who can possibly untangle a mess like that? You need someone who knows every single flight path, every hotel's live availability, every train schedule, and all of your personal preferences, all at the same time. You don't need a person for that. You need something else entirely. A new kind of intelligence. We're talking about an agentic AI, an AI that doesn't just answer your questions, it takes action for you. That is the hero of our story today.
Okay, whoa. I know this looks complicated, but trust me, this is the secret architecture, the mind of the AI that can fix our travel nightmare. This is the journey we're taking together today, and we're going to keep coming back to this blueprint as we uncover each piece of the puzzle. Our investigation starts right now.
So where do you even start with something like this? Well, every great agent, every truly intelligent system begins with a mission. And I don't mean a vague goal, I mean a crystal clear set of instructions that defines its entire reason for being.
See, the agent's mission isn't just book a trip. Its prime directive, its main objective, is to maximize your satisfaction. This is then broken down into core functions, like creating totally personalized itineraries. It's also tied down by hard constraints, things like your budget and, of course, safety. And get this, it even has a defined behavior. Be patient, be clear, and try to anticipate what you need. This isn't just a machine following orders, it's a dedicated partner with a real purpose.
Okay, so our agent has its orders. Great. But how does it actually remember you? How does it make sense of the world? How does it become aware of anything? To do all that, we have to build its brain. As it turns out, an agent's brain is built on 3 different kinds of memory that all have to work together perfectly. And what's really fascinating is how much they're like our own memory, though in some ways, maybe even a little better. Let's break them down.
First up, you've got short-term memory, or working memory. The best way to think of this is as the agent's RAM, or its mental scratch pad. It holds all the relevant info for the conversation you're having right now. I'm looking for a morning flight to Tokyo, window seat please. It keeps track of all that. But here's the key. Once the conversation is over, poof, that memory is wiped clean. It's fast, it's temporary, and it's absolutely essential for a smooth chat.
Next is the long-term memory. Now this is the agent's permanent library. This is where it stores your profile, your travel history, and all your known preferences, like the fact that you will always choose an aisle seat if it's available. It also holds this massive knowledge base of stuff like travel rules and facts about different destinations. This is how it remembers that trip you took last year and uses that knowledge to help you today.
And finally, we get to my favorite part, episodic memory. This is the agent's personal diary. It doesn't just remember facts, it remembers experiences. It remembers that the last time it booked a flight through a certain airport, there was a crazy long layover and the customer was not happy. So the next time, it will actively try to avoid that route for you. This is how the agent actually learns and gets smarter with every single interaction. It's incredible.
And this is where it all clicks. This is how all that memory becomes true intelligence. The agent takes what you tell it, sure, but then it combines it with all 3 of its memory systems. It pulls from its knowledge of global context, like travel advisories, and local context, like a giant festival happening where you want to go. It blends all of this together to get real-time situational awareness. This is how it knows to suggest a trip to Japan in the spring for the cherry blossoms. It's not just booking a flight, it's crafting an experience.
So our agent has a mission. It has a brain. It's looking pretty smart, but what if it gets a little too excited? What if it books that non-refundable once-in-a-lifetime hotel room before it's confirmed your flight is actually available? Yeah, total disaster. A truly intelligent system has to know not only what to do, but when and how to do it.
So how does our agent avoid making that kind of costly mistake? Well, it all comes down to the way it thinks. It actually has 2 completely different ways of processing information, and choosing the right one is the key to being both fast and safe.
Just look at these 2 pictures. On the left, you've got a single file line, slow, steady, one step at a time. That's what we call sequential processing. On the right, a massive multi-lane superhighway. That's parallel processing, doing a ton of different things all at once.
So the real genius here is knowing which road to take at the right time. For tasks that absolutely depend on each other, like, taking payment before confirming a booking, the agent must think sequentially. It's the safe, logical path. But for all the independent tasks, like searching for flights, hotels, and the weather all at the same time, it opens up the superhighway. It searches for everything in parallel, and that's where it gets its incredible speed.
All right, we've given our agent a mission. We've built its brain. We've taught it how to think. It's time. Let's go back to that master blueprint and finally see this whole system in action.
And here it is, the whole thing, the complete logic flow. The agent gets a task, and it asks itself one simple question. Are there dependencies here? If the answer is yes, it sends that task to the sequential queue, our safe, single-file line. If the answer is no, boom, it goes straight to the parallel queue, our super-fast highway. Only then does it execute the task, all while monitoring itself. It's elegant, it's efficient, and it's how you solve an impossible problem with maximum speed and zero mistakes.
The source material sums this up beautifully. It says that by building agents this thoughtfully with this kind of design, you're not just creating a system that works for today. You're creating an agent that's robust, adaptable, and ready to evolve for whatever challenges we throw at it next.
So, we've built the impossible machine. We've been inside its mind and seen how it thinks and learns. But understanding how it works, well, that leads to an even bigger, more important question. Can we really trust it?
We're going to explore that very question in our next explainer. Until then, Hari Har.